The ANOVA test is another test that could be conducted to find a significant difference or not, but for groups that are 2 or more, meaning more than 2 sets of data. Similar to the t-test, you will need to have a big sample size, not less than 20 or 30 for each group. You will also need to write the null hypothesis and the alternative hypothesis, and then find the p-value to determine if there is a significant difference between the groups or not. Your conclusion in ANOVA test, based on the p-value, is very similar to the t-test we have explained earlier. You can also use Microsoft Excel to calculate the p-value for the ANOVA test. Note that when we have one independent variable, we call this type of ANOVA test one-way ANOVA test. Don't worry about the other types, as we mostly use this type, which we will explain here. Let us see this example. Let's say that we have the following 3 groups, A, B, and C, and we want to see if there is a significant difference between the 3 groups or not. To make it easier, ensure that the data analysis tools is up, or you may need to install it. Click to the data analysis tool. Click on the data analysis toolbox and select the ANOVA single factor, which means one-way ANOVA, and then hit OK. In the input range, select the 3 groups with their headings. If you include the headings, ensure you say labels in first row. Select grouped by column because our data is in columns. Insert in the alpha level 0.5. Click on the output range and then select a clear cell where you want the ANOVA test results to appear. You can see here that Excel provided you with a summary statistics for each of your groups, including sample size, sums, average, and variance. The ANOVA test results underneath are what you need, and what is important here is the p-value or the probability value. Similar to t-test, if the p-value is lower than 5%, which is 0.05, this means that there is low probability that chance alone could produce the difference. This means that we are more than 95% confident that the difference is real and not due to chance only. So we can conclude that the difference between the 3 groups is significant and not due to chance only, and accordingly, we reject the null hypothesis and accept the alternative hypothesis. If the p-value is more than 5%, which is 0.05, this means that there is high probability that chance alone could produce the difference. This means that we are less than 95% confident that the difference is real and not due to chance only. So we can conclude that the difference between the 3 groups is not significant and is probably due to chance only. And accordingly, we accept the null hypothesis and reject the alternative hypothesis. A limitation of the one-way ANOVA, that it will only tell us if there is a significant difference or not between the groups, but it will not tell us which groups were different. See you next time.